One of the most defining traits of Geometry Dash is how you always move at a constant rate. For the most part, different speeds were not introduced until the level electrodynamics came out. However, we've all asked ourselves, how fast does the player actually move? Hello, Count Sacke here, back with another GD Dynamics video. In this episode, we'll finally be answering the old question of how fast does the player move? As of version 2.1, there are a total of 5 different speeds, 0.5 times, 1 times, 2 times, 3 times, and 4 times. However, we actually haven't proven that their names are what we call them to be, except 1 time speed, since that's the first type of speed that we've been introduced to. Before things get started, I should mention that you need to watch episode 3 in order for things to make sense. So go ahead and watch it, then come back here. Now for the most part, we'll be purely talking about speed, though just so you know, I'll use velocity because I want to. Look, today we're only talking about the magnitude of the horizontal velocity, okay? Now let's get into my methodology for calculations. I actually did a few live streams on this, but I'll explain it here. Simply put, we need to know 2 things to get the velocity: displacement and time. Measuring time is actually pretty simple. I programmed a stopwatch that starts whenever I press enter and would stop whenever I press the escape. Pressing enter in the GD level editor puts you in playtest mode, and pressing escape puts you in the pause menu and stops playtest mode. So how do we measure displacement? At first, this might seem really annoying and difficult, but luckily, when you go into playtest mode, there's this green line left behind on the path of the player. We can measure this line in pixels and convert it to blocks to ultimately figure out a velocity for the player. We can use this formula that I've derived to convert pixels to blocks. L is equal to d times 1b divided by beta. Now to calculate velocity, we take the distance in blocks and the time in seconds and plug it into this universal formula. Velocity is equal to displacement divided by time, so in our case, its velocity is equal to L divided by t. Seems simple, right? Wrong. Guess what? Turns out that the player's speed is not constant. No, JK, just kidding. Look, no. Stop. Okay, stop. There appears to be a margin of error whenever you measure the length of a line. One time I measured the same line, but at a different scale, and, well, the length was different. That's a problem! Unfortunately, we don't really have a better way to measure velocity, so instead we'll need to use statistics. Introducing Basic Stats 101 Crash Course, Sample, Mean, and Standard Deviation. A sample is basically a data from a portion of a population. We don't really need to talk about population, but just think of it as the total set of all data, which is represented as capital N. The total amount of samples is represented with the letter N. A sample is represented with either X or A sub n, where n is the nth sample in a dataset. Next is mean, otherwise known as average. This tells us which value the data tends to go toward. Basically, this is the value which data tends to be found around. Don't mistake this for mean though. The symbol of mean is x bar and can be calculated using this formula. X bar is equal to the summation of x divided by n. Finally, standard deviation. This is basically a measurement of precision or consistency. The closer the value is to 0, the more consistent the data is. There is another measurement of the consistency, which is variance, but it's basically the standard deviation squared. The symbol of standard deviation is sigma and can be calculated with this formula. Sigma is equal to the square root of the summation of x minus x bar squared divided by n. I'll introduce the central limit theorem, which basically says that as the sample size approaches the population size, the more data appears to be in this sort of shape called the bell curve. Well, so what? It looks cool, but what does it mean?
Basically, the mean of the sample is approximately equal to the population mean.
Alright, crash course over. Armed with these basic statistics concepts, let's relate things to our case. The samples would just be the individual calculated values of the velocity. The mean would be the exact real value of the player speed. but we need to take a lot of samples as the central limit theorem states. And we also want to make sure that we have a very, very small standard deviation, because when it's small, it means that the average or the mean is more likely to be the true value for the speed. As of now, I currently have a sample size of 30 for each speed. 30 is often referred to the size as where the values of a sample more accurately represent the population, but unfortunately, we have to take an infinite amount of samples to actually get the exact value of the speed. I don't have the time to do that, so I'll only start with 30. I'll come back to this episode when I do more, but keep in mind, I needed to take a total of 150 samples. And well, it's very time consuming to do this. Alright, so now let me show you the current values that I have found. Okay. Sorry, look, I'm really tired from doing all those samples. Anyway, these are the distribution graphs for each speed. Noticeably, the 3 times and 4 times speed appear to have some sort of normal distribution. Then we have this, which is a plot of all the samples that I took for each speed. And well, here's just a table with the summary of everything because, yeah. And when looking at this data, you can see that the standard deviations aren't that large, but definitely could still be smaller. I will have to probably come back to this one, but right now I'm really burnt out from doing all those samples, so give me some time to rest, like maybe some few months or something, maybe even next year, but yeah, give me some time, okay? Anyway, so yeah, we've finally come up with some sort of value to estimate the speed of the player in GD. I don't really know if anyone has done this sort of video on this topic before, and well, I'm happy to possibly be the first. Yeah, that's really about it for now, so thanks for watching and hope you enjoyed.